Hey students, good afternoon to everyone. Welcome back to another video tutorial from the AP3X Institute of Applied Mathematics Education. My name is Akin, your math instructor. And of course, this is a continuation tutorial video from my previous upload. You would have seen where we went through the fundamental aspects and application of direct and indirect proportionality questions, as well as a few variation questions. We touched on the basis of a few worded problems, but we didn't really get into depth. Now in this particular part 2 here, we're going to be going into more exam structure type questions, and we're going to be looking at how the questions can change variables, how the relationship between the variables can change, some worded problems. And let's try to see if we can comprehensively grasp this topic so that moving forward we don't have an issue with these types of questions. Of course, if this is the first time here on the channel, I do provide you with contents related to the Csec, CC, SLC, SEA, EDXLs and City and Guilds curriculum, math curriculum, but I primarily focus on contents related to Csec. Alright, but of course it's just math in general. So should in the event that you're doing a particular math problem and it's related to these types of questions, it should be very helpful. Of course, do not forget to hit the like button. It really does help the channel to grow. Share this to your math groups, share this to your friends, help to get the channel out there. Lots of tutorials are coming. At least tutorials are posted every single weekend on a Saturday and on a Sunday. You can also check in the description box below. You'll find contact details to the online classes that I offer tutorials. Feel free to hit me up on any of my social media handles and you can be able to join the class at a convenient cost to you. Right, but let's just get right into this particular tutorial here. I do hope that you were able to at least attempt question 2. If you haven't, then I would recommend that you pause the video, give it a try, and try to match your solution with mine. All right, I do hope that when you're watching this content, it is not watching just for the purpose of seeing me do the problem, but I'd love to see you apply and correct your mistakes if there's any. All right, let's kickstart this with a recap from our last session, our last tutorial video. Here we have question 2 that talks, it's a worded problem with a little bit of switching up with the relationship between the variables and the letters. Okay, so here we have the time taken T for customers to receive their food orders at a restaurant is inversely proportional to the square of the number of staffs S working at that time. Now let's identify some variables. It says that it takes 20 minutes for customers to order, pardon me, it takes 20 minutes from customers' orders being taken where there are 4 staff members only. So those 2 values are usually the values that are going to be aiding us in finding the constant of proportionality. Now the very first thing here is that they ask us for part A that we should write an equation in terms of T and S, or write an equation for T in terms of S. Now this tends to throw off students because a lot of the times when students are exposed to this particular topic, they are not exposed to how the structure of the question can be. But this is just simply asking you to write down the formula for the inverse relationship between the minutes and the staff members for the customers. So we're going to be using S and T, and so T represents customers, so therefore we're looking at the fact that T is inversely proportional, so that's division, so that's K divided by, say here, the square of the number of staff. So since staff is represented by S, we're going to be squaring the number of staff. So that's the formula there that we're looking at. T is equal to K divided by s squared. All right, fantastic. Part B, if the number of staff is doubled, how many times quicker will the food be served? Interesting. We first need to find the value of k, and let's see what happens here. So here we have t, which is the time taken, which is 20 minutes, and that's going to be equal to k, which is unknown, and number of staff working at that time is 4, so that's 4 squared. So then what we're looking at here is 20 is equal to k divided by 16. So therefore what we're looking at here then is cross multiplying, because the unknown variable is at the top. So therefore 20 multiplied by 16, that's going to give us k. Therefore 320 is equal to the constant of proportionality. Now what's going to happen then? If the number of staff is doubled, how many times quicker will the food be served? Well, this is an intuitive question, because since it's inverse variation, we know that if one quantity goes up, the other one goes down. So therefore it's inverse, so that means if the number of staff is double, then the time is going to be cut in half. And it kind of makes sense, because if it's inverse variation, if one quantity is doubled, then the other quantity is going to go down by the inverse of what causes the quantity to increase. So therefore the inverse of 2 then is going to be equal to a half. So this is more of an intuitive type question. Is it possible then to try to find, say here, use the equation? It's possible. If you guys can try to use the equation to determine the value of a half, then that would be good. But it's more of an intuitive question where thinking about it, say here you double the amount of workers that you have, then the time taken to get the job done is going to be cut in half. All right, if it's 4, then it's going to be cut into a quarter, that's more workers. 5 is going to be cut into 1/5, so on and so forth. So that was a very, very interesting question. I feel like this is an example that I would perhaps put on my quiz. I do hope that my students who are watching this perhaps will expect a question like that. Haha. Okay, let's see here then. Let's go on here to question 3. A is directly proportional to C. Let's write an equation for that. A is directly proportional to C. So A is equal to K multiplied by C. All right, there's no changes in the variables. Okay, and then they give us another one here that M is inversely proportional to the square root of A. So M is inversely proportional, so that's K divided by the square root of A, so that's the square root of A. So we have 2 formulas to work with here. All right, and as I said guys, for this particular tutorial we're looking at advanced questions, exam application questions. So if you were to see this on your quiz in the future, then you know exactly what is required. Let's go ahead here and try to find the question, answer the question. When A is 32 and C is 8, when A is 32 and C is 8, so A is 32 and C is 8, we have to use this formula. This is the formula that contains A and C. So A is 32, so that's 32. Let's just use an arrow to show you the formula that we're using. Okay, A is 32 and that's going to be equal to K is unknown obviously, and C is 8. So therefore if we divide both sides by 8, you're going to find here that in fact K is equal to 4. Okay, so this is the value of K. We may need to make a note of this, because it's the same question, but we have two different relationships between the variables. We move on next now that we will need to find, okay, it says when A is 16, M is 144. A is 16, M is 144. When A is 16, M is 144. So we're going to obtain another value for K here. So here, I'm just using this arrow. This is the formula that we're now using. So then A is 16 and M is 144, so that's 144 is equal to K, obviously is unknown in this relationship here, and say here A is 16, so it's the square root of 16. So then we have 144 is equal to K divided by the square root of 16 is 4. So if you were to go ahead then and multiply 144 by 4, we're going to find here that K is equal to 576. So that's 144 multiplied by 4. So K in this case here is 576. Alright, so let's make a note of this particular value of K here. Now they're asking us to find the value of M when C is 9. Find the value of M when C is 9. Interesting. Find the value of M when C is 9. Interesting. Very, very interesting. Alright, so what do we do then? We are looking at finding the value of a variable, but the variables involved in this question are from two different variation problems, or two different variation. So based on my experience here, this is kind of hinting to me that I may need to find the value of A. I will need to find the value of A here when C is 9, and then transpose the or substitute the value of A down here. Okay, so that's what I'm gonna have to do. I'm gonna have to find the value of C, okay, because M is the ultimate goal, to find M. So there's no C down here, but there's an A, and there's a relationship between A and C. So if I can use the value of C to find the value of A, substitute the value of A into this formula down here, then I can safely find M. Alright, so let's get to it then. Let's go down here. This is a very nice question. Really, really nice question. So let's rewrite our formula then. A here is equal to K multiplied by C. They said C is 9, so let's use that information. C is 9, and since we're using the formula K times C, we're going to use the value of K up here, which is 4. So that's 9, so that's 4 multiplied by 9. That will give me the value of A. So A here works out to be 36. Aha! So now, since A is 36, I can then transpose that value of A into this equation down here. So then I'll end up with, say here, M is equal to K divided by the square root of A. And then obviously then that M is equal to, I'm going to use the K value down here, 576, because that's the value of K in this relationship here. So 576 divided by A then is going to be 36, so that's the square root of 36. So that's going to be equal to, that's going to say here that M is equal to 576 divided by 6. So 576 divided by 6, and that works out to be 96. So therefore M is equal to 96. Alright, Alright, that was a very interesting question. Didn't actually work it out before I saw it. I worked it out on spot. So it required a little bit of thinking in relationships. So yeah, that is the solution. If you guys tried that from the previous video and you got it right, hit me in the comment section to let me know if you got close or you made a mess of the question. All right, let's move right along here, guys, nicely. So these are some other questions, but they're more worded form. Let's have a look at a few of these. All right, so we're warming up for the advanced questions. And I can think, I would almost say that that would have been the most advanced one that you're going to be seeing in this tutorial. Alright, so here we go. It takes 4 people 2 days to landscape a garden. How long would it take for 2 people to landscape the garden? I mean, this is kind of like the question they had asked us around here about if the number of staff was doubled, then how many times quicker will the food be served? It's kind of the same thing, because if you notice here that it takes 4 people to do the job in 2 days, we have decreased. It says how long will it take for 2 people, so we have decreased the amount of persons. We have decreased the amount of persons by a half. So we are expecting that the answer, without any calculation, that the answer should be 4 days. But let's do the math and see what happens. Okay, obviously you can see that this is an indirect proportionality question, because you have decreased the amount of people, so the time, naturally the time taken to do the job should take longer. So that is an up and down relationship. Pardon me, it's a down and up relationship. Decrease the amount of people, increase the amount of time. So again, if you want to use the traditional way, or you want to use the formula here, y is equal to k divided by x. I'm using the number of people to be y and the time to be x. So 4 people, remember that we have already guesstimated our answer to be 4. But let's see here. K is unknown, so y is 4 people. K is unknown, x is 2. So therefore then we can easily work this out, that k is equal to 2 times 4, k is equal to 8. So therefore then, if we rewrite the formula y is equal to k divided by x, then naturally then you're going to find here that the number of people decrease, so that's 2, that's equal to k is 8 divided by x then is unknown. So if we swap the x and the 2, then x is equal to 8 divided by 2. Naturally then you're gonna find here that x is equal to 4. So we have already predicted the answer, because like I said, this is very similar to what they had asked us earlier about doubling the time, and doubling the time, what would happen to the amount of people, or cutting the amount of people in half, what would happen to the time. So that was kind of an obvious question. Hopefully you guys got a hang of that. All right, and here's an example here that asks us to write our formula. Y varies directly, or y is directly proportional to x when y is 36 and x is 4. Find the formula of y. Find a formula for y in terms of x. So direct proportion is y is equal to k multiplied by x. That answers this particular question here. That's the relationship. Okay. So then we'll find the value of y when x is 3. Obviously we can't find y unless we have k. So therefore y is equal to k multiplied by x. They gave us an initial value of y, which is 36. K is unknown, and x here is equal to 4. So if we divide both sides by 4, then it works out that k is equal to 9. You guys would have gone through video 1, so a lot of the stuff that I'm doing here would have been already explained. Let's rewrite our formula. Y is equal to k multiplied by x. They said here find y, so y is unknown, k is 9, and x here is 3, so y is equal to 18. Right, and that gives us the solution for that problem. right? Wow, but they gave us 3 marks just to write down the formula and 1 mark for the answer. I think I would have given you the opposite. I would have given you 1 mark for the formula and 3 marks for the working out. All right, and of course you guys can try this one down here. X is inversely proportional to the square of m. You would have seen examples like that one before. Hit me up in the comments to let me know what your solution is. I will let you know. Let's have a look at this one. P is directly proportional to the square root of r. You would have seen example questions with the square root of r already. All right, let's have a look at this one. This one looks to be interesting. I'm getting all my questions, guys, from online. So if you need a link towards how to get these type of questions, I will source a link in the description box below. You can click on the link and you'll find questions to practice besides what's on here. It's third space learning, a resourceful learning platform to which you can get lots and lots of practice questions on various topics in math. Let's have a look at this one here. P is directly proportional to the square root of Q. So direct, so that's P equals K multiplied by the square root of Q. Right, so we have that because it's direct, so it's multiply. And let's say here that R is inversely proportional to P cubed. So R is equal to inverse is division, so that's K divided by P cubed. So we have 2 formulas here. P cubed. Let's see what they're asking us for here. So when Q is 49 and P is 35, when Q is 49 here and P is 35 here, okay, we can find K. So that's 35. And I hope that you guys are actually pausing the video, working the problem out, and then matching my solutions with yours so you can see where you're making the error, if you're making any. K is unknown and Q, according to the question here, is in fact 49. So that's the square root of 49. So 35 is equal to K multiplied by 7. Square root of 49 is 7. So if we divide both sides here by, say here, 7, then K works out here to be 5. So when Q is 49, P is 35, you are to find P. So when P is 2 and R is 16. So let's go over here. Okay, so we're looking at P. We're looking at P and R. So that's over here. So P is 2 and R is 16. So that 16 is equal to K, which is unknown, and P, which is 2. So that's 2 cubes. We're looking at 16 is equal to K divided by 8. So then this looks to be, say here, 128. Pardon me, let's just write it down. Okay, so that's 16 multiplied by 8. That's equal to K. So let's see here. 128 is equal to K. This is kind of similar to the question that we just worked earlier. Find the value of R when Q is 4. Find the value of R when Q is 4. So we're looking for R, which is in this formula over here, but we're looking for Q, but we have Q when Q is over here. So this kind of suggests to me that I need to find P and then transpose the value of P over here in order for me to find R. This is a really nice exam question. So that's what it suggests to me. Okay, I'm looking for a variable that is in one formula, but they've given me the value of the other variable that is in another formula. So we need to do a little setup here. All right, let's do it. Let's take our time here. Let's find P over here, okay, by using Q to be 4. So P is equal to, say here, K multiplied by square root of Q. So P is equal to K, we have already obtained to be 5 over here multiplied by the square root of q, which is 4. So p works out here to be 5 times 2. Square root of 4 is 2. So p here works out to be 10. So we can then transpose the value of p over here to obtain r. So therefore we're looking at r is equal to k divided by, say here, p cubed. So r is what we're looking for, and k over here we had worked out k to be 128. So 128 divided by p in the question here, we just worked out p to be 10. So that's 10 cubes. Alright, p is 10. Let's double check, make sure that we are right. I think we have it right. This is 10 cubes, guys, so that's r is equal to 128 divided by 1000. So it works so that r is equal to 0.128. I think we are right. We are correct, I think. Yeah, it looks like we are right. Okay, q is 4, square root of 4 is 2. We had calculated r to be 5, k to be 5, so 5 times 2 is 10. Transpose over here, p, okay, looks to be right. All right, so it's 0.128. All right, beautiful. All right, let us continue then. We're looking at this one comes up then, this particular table form. All right, we have to look out for the table ones as well. And there's a relationship between the letters. I tend to always give my students the table where there is always 2 missing values. This one comes across a little easier because there's only one value that you have to find here. So example 3 from this particular page from Third Space Learning, y is directly proportional to x squared. So we need a formula then. Y is directly proportional to k times x squared. Alright, calculate the missing value of p. We know that we can't find a variable unless we have the value of k. So we can use either the 2 or the 2 and the 12 or the 3 and the 27. Either ways you're going to be able to get the answer. Alright, so let's do both. Okay, show you that it's the same. So in this case your y is 12 and k is unknown and x is 2. So 12 is equal to k multiplied by 4. If you divide both sides by 4, then you're going to find here that k works out here to be 3. If a student decides to use the 3 and the 27, then of course 27 is equal to k multiplied by 3 squared. So 27 is equal to k multiplied by 9. 27 divided by 9 equals k. You'll realize that k here works out again to be 3. So it goes to show that it doesn't matter which pair of values you use, you're going to still obtain the value of k correctly. Alright, so let's just erase this one here because that was just proof that you could use either pair of values. We're looking for here, so y equals k multiplied by x squared. This time it seems as if y is missing because y has the variable p. So we're going to replace y with p. K is in fact going to be 3 multiplied by x. In this case is up top, x is 4. That's the column that contains the 4. So that's 4 squared. So p is equal to 3 multiplied by 16. So p works out here to be 48. Alright, nice question. Let's move on to example number 4. We're just running through these examples, guys. Okay, y is directly proportional to x. Oh, this is an easy one. So y is equal to k multiplied by x. There's nothing much here. So a florist uses ribbon to trim a bunch of flowers. That's the formula. 80 centimeters of ribbon is needed to make 2 bunch of flowers. So let's use those two values then to find the value of k. Alright then, 80 centimeters, so that's 80 is equal to k is unknown and the bunch of flowers is 2. So if we divide both sides by 2, 80 divided by 2 gives us k. The constant of proportionality here is 40. Hopefully you guys got that. If you guys are wondering why I'm moving so fast, there is in fact another tutorial video which I went very slow in teaching you these application concepts. So we're just speeding up a little bit here, ensuring that we run through all these practice questions. The florist needs 9 bunch of flowers. So therefore, since bunch of flowers was x and the ribbons needed was y, they are basically telling us that x is 9. So the florist has 9 bunch of flowers to trim today. How much ribbon will be needed? So how much ribbon, which is y, how much y is what you're looking for. So y is equal to k multiplied by x. Y is unknown, k is 40, x is 9. So they need 360 centimeters of ribbon. And it makes sense. Alright? We needed 80 to make 2. And so 2 into 9 goes 4.5. And 4.5 times 80 is 360. Alright? Nicely done. Not too bad. Moving on to example number 5 here. Y is directly proportional to x squared. We have already looked at examples like this. So y is directly proportional. So that's y equals x squared. Pay attention to the change in the variable. The surface area A of a cube is directly proportional to the square of its side length L. So we have changed the letters that we're using. So we're using A and L. So in this case here, A is going to be equal to K multiplied by L squared, because it's the square of the side length L. So it's the square of L. Okay. You guys don't necessarily have to write the actual letters. If you guys want, you can. But I kind of prefer to always use the variables that I'm looking at so I don't get confused. So this is my new formula then this is my adjusted formula. A cube with side length 3 has a surface area of 54. So the side length is 3. Earlier we assigned okay, so A, so the side length is 3, so length, so okay, so L is 3 and the area is 54. So in the formula, A equals K multiplied by L squared. 54 is equal to K, which is unknown, and the side length here is 3, so that's 9, that's 3 squared. 54 is equal to K multiplied by 9. So if we divide both sides by 9, that will give us K. Therefore, K is equal to 9 6 9 5 is 45, 9 6 is 54. So 9 into 54 goes 6. Okay, so that's the constant of proportion. Hopefully you guys are following, because of course this would have been tough. We would have done examples like these in our previous tutorial and even earlier in this video. So this should not be a challenge. You should be flying through this as well, at least faster than I am. We're to determine the side length of a cube with a surface area of 600. So we are given the area, which is A, to be 600, and we're looking for L. So once again, we write our formula. A is equal to K multiplied by L squared. So that's 600 is equal to K was just calculated to be 6 multiplied by L squared. Alright, so we have to get rid of that 6 to isolate the L squared. So 600 divided by 6, that's going to be equal to L squared. 600 divided by 6 is 100. That's equal to L squared. And we learned earlier that to remove the square, we have to square root. So the square root of 100 is equal to the square root of L squared. Square root cancels the square, so L, which is the side length, is equal to the square root of 100, which is 10 centimeter. Alright, so not bad. I thought the questions were actually going to be a little bit more difficult, even from the perspective of a student, but I'm almost sure that my students are running through these problems. It's not taking them much time. Example number 6 here. When you read this, it probably comes off a little bit awkward with these grams per centimeter cube, Please don't pay much attention to the unit of measurement. The unit of measurement doesn't have anything to do with your calculation. It's just telling you the unit of measurement for whatever we are talking about. Density is gram per centimeter cube and volume is centimeter cube. Alright, so do not put this unit of measurement in the calculation, just focus on the numerical values. Alright, so y varies proportional to the cube root of x. Let's look at that. Y is directly proportional, so that's k directly is multiplied. Cube root, so that's the cube root of x. Alright, so we looked at questions earlier with cube root. Let's look at what they're asking us to do here. Let D represent the density of the object and V represent x cubed. Let D represent the density of the object and V equals x cubed represent the volume of the object in terms of the side length x. Okay, so a block of ice has a density. Let's first write the formula. So V is equal to, say here, the k multiplied by the cube root of x, because that's what they said. Alright, beautiful. Okay, so a block of ice has a density of 0.9 grams per centimeter cube. So 0.9 has a volume, it has a density. So the density, okay, so we're gonna have to use D here. So I think the formula has to be D, which is the density, and the volume, which is x cubed. So okay, so that's the formula that we're using. So the block of ice has density 0.9, so that's this here, and that's equal to k, obviously as unknown, multiplied by, it has a volume of 10.8, so that's going to be multiplied by the square root . I think maybe we need to revisit the formula here. Okay, it says here that let D represents the density of the object and V is equal to x cubed. Okay. Alright guys, so we're going to be moving on to the next question here, which is example 6, and it says here that y is directly proportional to the cube root of x. Let's create our formula. So y then is equal to the cube root of x, that's y is equal to k multiplied by the cube root of x. Okay, let's hold on to that. Let's read down here. It says that let D represent the density of the object and V, which is the volume, is equal to x cubed. Represent the volume of the object in terms of the side length x. Okay, hold on, let's read again. Let D represents the density of the object and V equals x cubed represent the volume of the object in terms of the side length. Okay, a block of ice has a density of 0.9 grams per cm cube and the volume is 10.8 cm cube. So we are using D and V, so it should safely say then that the density would represent y and the volume would represent x. So we're looking at direct variation, so that's D is equal to K multiplied by V. Now V is tricky because V is x cubed, but the x, I think it's in terms of the side length, so we're going to be just using V for now. I'm going to be using V for now. So D is equal to K multiplied by V, noting that V is the actual volume, but in terms of the side length is going to be x squared. So in the event that they ask us something later on about side length, we may have to do a conversion from V to being x cubed. Replace V with x cubed. Let's see if we can find the value of, in fact, K here. So then D is equal to K multiplied by V. The density is 0.9. K is unknown, obviously, and the volume here is 10.8 cm cubed. So we know that the cm cubed let us know that that's the volume. So that's 10.8. If we divide both sides by 10.8, then K works out to be 0.9. We're going to divide both sides by 10.8. So K is equal to then, let's go on our calculator. 0.9 divided by 10.8. We get K here to be equal to, 0.083 recurring, 0.083 recurring. All right, so that's K. It says given that D is directly proportional to V, so D is equal to K times V. Determine the side length of the block of ice with the same mass but a density of 0.92. So 0.92 K is in fact 0.083 recurring multiplied by the volume. This time we don't have the volume, but we have the volume in terms of x. So we're basically converting volume here to x cube, because if you cube the length of a prism, of our cube, then you're going to get the volume of the prism. So in this case here, we're going to convert V here to x cube. Okay, because it did say it up here that V is equal to x cube in terms of the side length. So then here that if we divide this into this, so that's 0.92 divided by 0.083 recurring, 0.92 divided by 0.08333. I could add a couple more threes. I should get here that x is equal, so that's equal to x cubed. Okay, so then we end up with x cubed being equal to 11.04. So we basically then need the cube root. So x then is equal to the cube root of 11.04. So if we find the cube root, let's see here, the cube root to be 2, so that's x is equal to 2.22. all right, this was definitely a tricky question, perhaps the hardest one of, this was a tricky question and probably the hardest one of all. I think I'm looking at it. I'm not sure if I've made an error somewhere, but I think it's okay because I actually didn't work these questions. I just got them off the site and decided that to come online here and work them with you, which again I can safely say that that's not advisable because it makes me look a little bit unsure. But I think I did okay. The side length here is 2.22. That will give me a volume here of 11.4. Okay, looks to be okay. All right, so I think that is it. That was a tricky question, tough one, but it happens. All right, I can't say for certain if you're gonna, depending on the level of math that you're doing, you may or may not get, but I've never really seen a challenging question like this at the Csec level. But that is it, guys. That is it. All right, but for the most part, the whole entire video highlighted a lot of skill set that we need. All right, we're going to be taking the positive from this video and we're going to be moving forward. All right, do take care until next time. Until then, I'll see you in another tutorial. Coming up on the channel is going to be the introduction to algebra, so look out for that video. That's going to be posted a bit later on, a couple hours from now, so do check that out. All right, until then, continue to practice with consistency and you'll become a better student in no time. Until then, take care. Bye bye.